Good morning, all of you. My name is Arvind Gautam, and I am working as assistant professor in Ajay Kumar Garg Engineering College and in CSE department. Today topic is structure analysis and structure design, and we will discuss about the some merits and demerits and the methodology behind the JSD model as well. Okay, so this topic is based on the object oriented programming. Previously we have discussed some topic like what is UML and their principle behind it, and we have discussed about what is object, what is classes, some basic definition about the object oriented programming. Okay, now the SA and SD structure. So till date we have discussed all the basics and some important topics from the object oriented programming. Okay, so SA is a structure analysis and SD is a structure design. What is that? Is this techniques basically based on the 4 basic methodologies, and these methodologies are Constantine and Jordan's methodology, first Hatley and Purvis methodology, Gain and Sarson's methodology, De Marco and Jordan's methodology. So basically SA and SD methodology based on these 4 principles, and SA technique can be used to perform high level design. When we design the high level, so we will use the SA and SD techniques. Okay, what is SA-SD methodology? Consists of 2 distinct activities. First is structure analysis and second is structured design. What is that? Structure analysis. Structure analysis says that when we dividing or decomposing the function into a smaller parts, or we can say that analyzing the function or large function or dividing it into a smaller function. Okay, that is structure analysis. Okay, analyzing the function or large function and dividing it into a smaller function, that is structure analysis. And what does means structure and design? In structure design, so whatever the function we have decomposed, again making those smaller function into a formalized or a formalized module, okay, or into a formalized structure. A module structure is formalized, that is means nothing but a proper structure. Okay, so having all those small methods, taking all those small methods, making them into a one structure. Okay, that is a structure design. And we can also say that taking the small function and making them into a appropriate structure. Okay, that is a structure behind that. This is the methodology behind those. So what is structure analysis? Analyzing the function or large function and dividing into a smaller function, that is structure analysis. And structure design, taking the smaller function and making them into an appropriate structure, that is a structure design. Okay, during structure analysis functional decomposition take place, and during structured design module structure is formalized. Okay, and what is functional decomposition? Each function is analyzed in which hierarchical decomposed into a more detailed functions, and second point is simultaneous decomposition of high level data into more detailed data. Okay, when we decompose the functions in more detailed data, so we understand the data very easily. Structure analysis, in which transform a textual problem and description into a graphic model. Okay, we have done this using the data flow diagram, DFDs, and DFD, what it does says that graphical represent the results of structure analysis. Okay, structure design, all the function represent in the DFD mapped to a module structure. The module structure also called as the software architecture. Okay, so we divide the function into a smaller function, so we can understand easily what does mean the each entities their working scenario. Okay, and a structure design make them into a proper structure. Okay, that is called the software architecture. What it looks like after the all the formalized and all the small parts are get together, and that is a proper structure, that is called a software architecture. Detailed design, software architecture refined through detailed design, and second point is detailed design can be directly implemented. Okay, when we have to use a conventional programming language. Okay, for this. Okay, and in structure design, when we use to map to a module structure through the data flow diagram, so through DFD we have been representing whatever the function that are being represented in the data flow diagram, identifying the flow of data from one function to another function, and identifying those, we can make those functions into one module. So this is the basic idea behind the DFD. Okay, and what is the major difference between the structure analysis versus structure design? So major difference between the structure analysis and structure design is the purpose of structure analysis capture the detailed structure of the system as the user views it, and second point is purpose of structural design arrive at a form that is suitable for implementation in some programming languages. Okay, so structure analysis basically I told you that it is in which we divide the function into a smaller function. Okay, so in structure analysis is representing textual information or representing whatever the function or operation we are having or functional requirements we are having. So framing those functional requirements into data flow diagram. Okay, in structure analysis. So structure design, and second point in structure design, what is the purpose of structure design? I have told you that in structure design we compose the functions in a proper structure. Okay, so we can say that in structure design identifying the functions that are operating, identifying the function and mapping those functions into a module structure, okay, is a structure design. Okay, so this is the main basic difference between the structure analysis and the structure design. And structure analysis and structure design basically based on these two principles. What is that? Top down decomposition approach, and second is divide and conquer principle. What it does is it says that in top down decomposition approach, so in top down we decompose, okay, we decompose the functions into a smaller functions, okay, or dividing into a smaller function, a function dividing into some other smaller functions. That is top down decomposition. And in divide and conquer principle, and in divide and conquer principle, what it does means, in divide and conquer principle is the vice versa of top down approach. In top down decomposition, we decompose the functions into or smaller in other smaller functions, and in divide and conquer principle, we again compose the divided or a smaller function into a proper structure, okay, or we can say that in a function. That is a divide and conquer principle, okay, in which each function is considered individually, that is isolated from other functions, and decompose functions totally disregarding what happens in other functions. Okay, graphical representation of results using data flow diagram or bubble chart. Through data flow diagram, I have said that we can understand easily what is the each entities, we can identify what are their work and how one entity is related to another entities and what they are working behind that. That representation we can shows through the graphical representation, okay, that is data flow diagram. Okay, so in top down decomposers, we decompose the functions into a smaller function, and again divide and conquer principle, we compose the smaller function and compose in the proper function or proper structure, we can say that, okay. Next is data flow diagram. In data flow diagram, DFD is an elegant modeling technique useful not only to represent the results of structure analysis, applicable to other areas as well. Example, for showing the flow of documents or items in an organization, DFD technique is very popular. It is powerful and yet simple to understand and use. Okay, I have said that in DFD, each entity, how one entity is related to another entities, and what is the major working of one entity and another entity. So we can represent by the data flow diagram. It is a hierarchical graphical model, shows the different functions or process, okay, of the system and how the data interchange among the process. Okay, one entities and one process, what the data they are interchange among one process to another process, we can show through the DFD, okay, data flow diagram. And the major concept behind it, it is useful to consider each function as a processing station, okay, and each function consumes some input data, okay, and produce some output data. What it does means, each function consumes some input data, means entity what it takes and what it produces, what is that particular entities what is producing, okay, what is the output it will that particular entities will produce, that shows from the DFD, okay. This is one example about the data flow model of a car of a assembly unit, okay. We can understand how the DFD is working, okay. First is before going to start this example, in which it shows that we have to create the design of a car, okay, and then we have to present the design and shows these are the operations, these are the operations, okay, these are the operations that are built, these are the functional requirements, okay, these are the functional requirements that are being presented with this design, okay, satisfying the customer and the end user, okay. Okay, so here we can say we can say that a engine store and a chassis store, these are the major part of any car engine or any vehicle engine, okay. So these are formed of fit engine, okay, and door store, these are also very important entities of any vehicle. So this will fit the doors, and part assembly and wheel store, this is also a very important entities of any vehicle, this will have to fit the wheels, and after that all the functional get together, and finally we are producing, after that test, we are producing the final product, that is car, okay. So this is the we can say that this is the structure analysis, where we are dividing the a function into a smaller function, and after that in a structure design we okay, we create a software architecture, we can say that, okay. And here in this we divide the function into a smaller function, and after that all the in structure design we compose the smaller function into a proper structure. Okay. And another some important points of DFDs are DFD model uses limited types of symbols, simple set of rules, easy to understand. It is a hierarchical model. Okay, because it is very easy, so it is also very easily to understandable. Okay, because human mind can easily understand any hierarchical model. So in a hierarchical model, we start with a very simple and abstract model of a system. Second point, details are slowly introduced through the hierarchies. These are the some basic other points of DFD. Okay. Hierarchical model in which we bigger entities divided into a smaller entities. Okay, sub parts, we can say that major parts are divided into sub parts, and after that sub parts are further divided into other sub parts. Okay, and further the sub parts again divided into another sub part. This will it will we can source through the this hierarchical model. The larger parts are divided into a smaller parts. Okay, so these are the some basic this is the some basic ideas behind the structure analysis and structure design. We have seen through the one example. Okay, how it deals and how it is working and how we can formulate or how can we structure we can create a proper software architecture or a software. Another topic is Jackson structure development. Okay, that is JSD. We can say that JSD was introduced by Michael Jackson in 1983. Michael Jackson is a programmer who developed introduced this methodology, that is JSD. So in JSD, the fundamental principles of JSD is that it focuses on describing the real world by the system. That is, its main focus is to map the progress in the real world rather than specifying the functions performed by the system. So its main focus is to map the progress in the real world. Okay, so what it does means, JSD, we are not only focusing on functions and features of the system, but we also mapping the progress of the real world with the timeline. Okay, this is the basic ideas behind the Jackson structure development. Okay, and another point is that Jackson system development is a method of system development that covers the software life cycle either directly or by providing a framework into which more specialized techniques can fit. Okay, JSD can start from the stage in a project when there is only a general statement of requirements, or however projects that have used JSD actually started slightly later in the life cycle. So doing the first steps largely from existing documents rather than directly with the users. So basically in JSD deals with the real world. Okay, So not focusing on the functions and features of the system, but we also mapping the process of the real world with the timeline. Some basic phases of JSD, what are their phases as? First is modeling phase, specification phase and implementation phase. First is modeling phase. In the modeling phase of JSD, the designer creates a collection of entity structure diagrams and identifies the entities in the system, the actions they perform, the attributes of the actions and time ordering of the actions in the life of the entities. What it does means, the type of language you are using to code the software, okay, you are using the software, what you have to find out, if you are using, just suppose if you are using object oriented programming, so in object oriented programming, so you have to find out some basic idea of the object oriented programming. You have to find out the object and classes, and after that you have to develop that, you have to develop the proper diagram by using the objects and the classes. Okay. Okay. And second is specification phase. This phase focuses on actually what is to be done. Previous phase provides the basic for this phase. A sufficient model of a time ordered world must itself be time ordered. Major goal is to map progress in the real world on progress in the system that models it. What it does means, in specification phase, what object is performing at what time, and after that what is the sequence of that particular object performance. Okay, this is the major points and major methodology behind this specification phase. We have to find out the time and objects performing time, and after that we sequence of that particular object performance as well. Okay. Third is implementation phase. In implementation phase, JSD determines how to obtain the required functionality. Implementation way of the system is based on transformation of specification into efficient set of process. The process involved in it should be designed in such a manner that it would be possible to run them on available software and hardware. So basically what phase, talking about the code and the deployment. Basically we are discussing about the what is the code and how to this develop deployment, how it is deployment. Basically deployment phase says that when we are installing the particular software on the certain type of hardware at the user end. Okay, so that is a deployment phase, we can say that. So in implementation phase, basically we talk about the code and the deployment phase. Okay, so these are some basic phases of JSD: modeling phase, in which basically we have discussed the what type of language you are using to code the software, and you have to find out if you are using object oriented programming. Okay, whatever you are using language, so you have to find out the if you are using object oriented programming, so you have to find out the object classes, and after that you have to develop the diagram. Okay, what modeling phase says that, and in specification phase you have to find out the performing and what time it performed, and after that you have to find out what is the sequence of that particular object's performance. Okay, and in the implementation phase, basically we talk about the code and the deployment phase. Deployment, how it does deploy, how it deployed. Next point is Jackson structure development. Initially there were 6 steps when it was originally presented by Jackson. They were as below. First is entity action step, second is initial model step, third is interactive function step and information function step, fourth, fifth is system timing step, and sixth is system implementation step. Okay, first step is shows as implementation phase, or modeling phase. We can say that modeling phase. First entity and action step, we can say says that it is a modeling phase. Okay, and the second is initial model steps, interactive function step, information function step, and system timing step. All these functions related to specification phase. Okay, and last is system implementation phase. This we can say that it is a implementation phase. Okay, so first is entity action step is a modeling phase, and initial model step, interactive function step, information function step, and system timing step is a specification phase. Last is system implementation stage is a belong to implementation. Okay, where we basically we deals with the code and the code and the deployment phase. And what is the merits of JSD? It is designed to solve a real-time problem, and JSD modeling focuses on time. It considers simultaneously processing and timing. It is a better approach for microcode application as well. And what are the demerits of JSD? It is a poor methodology for higher level analysis and data based design. Okay, JSD is a complex methodology due to pseudo code representation. It is less graphically oriented and compared to SASD or OMT modeling technique, object modeling techniques, and it is a bit complex and difficult to understand. These are the some basic merits and demerits of JSD. Okay, and thank you for the today class.